Welcome to my channel. So let's have a look at problem 376 together. So this is a Vigo subsequence, the daily challenge problem. So for this problem and in this video, we'll share a greedy method solution. First, I'll read through the statement of the problem, and then we will analyze the examples by using several pictures, and finally we share the code. First, let's look at the statement of the problem. So a Vigo sequence is a sequence where the differences between successive numbers strictly alternate between positive and negative. So in other words, the monotonicity changes. So the first difference, if one exists, so in other words, the sequence is long enough, maybe either positive or negative. A sequence with one element and a sequence with two non-equal elements are trivially Vigo sequences. So this sentence actually tells us how we initialize the procedure. We'll see later. So here are examples of Vigo sequence and non-Vigo sequence. So in the Vigo sequence example, the monotonicity changes and alternates. In the non-Vigo sequence, so this piece, so actually continues increasing. So overall, it's not a Vigo sequence. So a subsequence is obtained by deleting some elements, possibly 0, from the original sequence, leaving the remaining elements in their original order. So this definition of subsequence is in distinction from the subarray. The latter requires a continuous piece. So given an integer array nums, the problem requires to return the length of the longest Vigo subsequence of nums. So here we are required to return the longest length, not a Vigo subsequence. So here are the examples. So in example 1, so this is an Vigo sequence example. So the return is 6. You see the monotonicity alternates. So in example 2, the output is 7, and the explanation gives such a Vigo sequence and analyze their monotonicity or differences. So in example 3, so this example is sort of trivial. The reason is that this nums array is monotonely increasing, right? So you can choose any two of the numbers here to use as the longest Vigo subsequence, and the length is 2. So the constraint about this problem is that the length is less or equal than 1000. So 1000 is not a very large number. So nums is in the range 1000. So actually we will see the constraint on the range for our method does not play an essential role. In other words, we can relax this constraint or just ignore this constraint. So here the follow-up is that could we solve this problem in linear time? Yes, we shall solve it in linear time. So with that said, let's have a look at the method we're going to use. The method is a greedy method here. So the idea actually is very simple and intuitive. So we want to, just for each number we see, when we traverse the nums list, we check if it produces a new trend or new monotonicity. So new means compared with the previous one. For example, previous is increasing, now the new should be decreasing, and vice versa. So with that said, let's have a look at the demonstration. So here we give 4 examples to help build the intuition. So actually, if we have some background in the in crossing or Brown emotion or something alike, so this solution to the problem should be straightforward. So if we look at example 1 here, so the nums list contains all constants. So in this case, the return is 1. So you can choose any one as the longest Vigo subsequence, but we cannot add more, right? So this is one. So in example 2 and example 3, so the sequences are monotone increasing and decreasing respectively. So both return 2. So you can choose 2 of them if they are not equal. So for example, this one and this one, or this one and this one. Similarly for example 3. So example 4 here actually is cooked up from example 1 in the problem statement by adding 2, 3, 8, 8. So the reason we add these 4 elements is to fix idea in the general case, right? So in this example, if we look at this, so if we look at it from index 0 to index 3, so this part is monotone increasing. So if we look at this part, the longest Vigo subsequence has length 2. So you can choose this one or this one or this one and this one. So now if we look at this one up to index 4, so this number produces a new trend, right? So originally it's increasing, now it's decreasing. So the length up to this part actually is 2, is 3. So 1, 2, 1, 2, and 3. So this is the longest. But we cannot choose this one, right? So if we choose this one and this one, so it does not produce new trend, right? So in the selection. So therefore, overall, we should choose the lowest and the highest in a local increasing or decreasing piece. So once we are here, so we have length 3. Then we look at this point. So this point produces new trend, right? From decreasing to increasing. So we increment the length by 1. That is 4 so far, right? So now if we so this 1, 2, 3, 4, and then up to here, so we produce new trend again. So we get length 5, and up to this point we do not produce new trend. So still same length. So now up to here we still do not produce new trend, but in general we should choose this point and this point. So this get 5, and up to this point it produces new trend again. So we get 6 overall. So that's the main idea. So one point we want to emphasize is that for each of the monotone subpiece, we should choose the lowest and highest to produce longest Vigo subsequence. So that explains greedy. So here we choose this one, and we choose this one, and then we choose this one, we choose this one. Then from here up to here, it keeps decreasing. So we choose this one and this one. So that we can produce longest Vigo subsequence, right? So if we choose this one, and then we directly jump to this last one, it does not produce new trend. Therefore, it does not increase the length. So that's about the illustration and fixing the idea. So now let's come back to the problem statement and do the code. So before we do the code, I want to make a challenge. So can we find such a sequence, such a Vigo sequence, subsequence? So I would say with the solution we are going to provide, so it's sort of a trivial task. And also, the first reaction for this problem might be dynamic programming. So you can try this method, try DP if we like. So now let's come to our method. So for this, first I'll track the information for the length of nums. Here I'm according to this sentence. A sequence with one element or a sequence with two non-equal elements are trivially Vigo subsequence. So first I'll use that sentence. So if length is less than 2, so I'm going to just return that length. So that's sort of straightforward. So now basically I want to look at the first two elements to examine if they're equal or not. So I would introduce a variable called trend. So notice that the num length is greater or equal than 1. So if we exclude this case, so the length is always greater or equal than 2. So we can do this, right? nums1 minus nums0. So for this trend, it can be positive, can be negative, and also can be 0, right? So then we are going to define a result variable whose last stage or final stage is what we want to return. So it equals 1 if trend equals 0. So in other words, the two numbers are the same. So otherwise, so we're going to return 2, right? So this is the start also is from this sentence. So next, basically, we want to traverse the nums list. So to examine the trend, right, for I in range. So we shall start from 2 and then up to the end. So first, when we look at the new numbers, let's see if it produces new trend. We'll introduce a temporary variable called new trend, which is nums I minus nums I minus 1. So this new trend actually can have three possibilities. It's positive, negative, or equals 0. But if it equals 0, for example, it does not produce a new trend. So the only cases that this new trend is different from the previous trend is that the new trend is positive and the previous trend is negative. But from the starting, the trend can be 0, right? So in other words, the new trend is positive and the previous trend is less or equal than 0. It's negative or no trend. Or the new trend is negative and the previous trend is positive. But from beginning it can also be 0, right? So basically we want to check if new trend is greater or equal than 0, is greater than 0, and the previous trend, let's call it trend, is less than 0, right? So in general, this is a general case, or equal to 0. So the equal to 0 actually only happens at the first two numbers, right? That will play a role. So, and if or the new trend is less than 0 and the previous trend is greater or equal than 0. So in this case, we're going to update the result by incrementing it by 1. And also we reset the trend to be the current trend, new trend. From this code, actually, we can think a little bit further. So the trend when we reset is always positive or negative. So the only possibility that the trend is 0 is at the very beginning when we starting the procedure. So with that said, actually that's it for the solution. So we're going to return the result. So let's first do a check. Yeah, it passes the example we cooked up. So in example 1, so I add 2 and 3 and 8. This actually, the example here we are testing is more generic than example 1, example 2, and example 3. For example, this piece, if you look at this piece only, this is nothing but example 3. So if we look at, if we look at 1, 2, 3, 7 only, so this is example 3. So if we deleting 2, 3, 8, 8, it's example 1. So with that said, I guess we're ready to check the generic case. Yeah, it passes the generic case. So I would say this code is a little bit compact. So if you has confusion, so basically you can do something like this. Let's copy this one, and then what we want to do is that let's copy this whole code. So you can write it in other way. So for example, so you can do something like this. If new trend is 0, so it's just a continue, right? So otherwise, so you compare. So if new trend is positive, then you consider the case that if the previous trend is less or equal than 0. So in this case, you're going to update the result and set the trend to be new trend. Right? Otherwise, so to pick new trend is less than 0, because we have already excluded equal 0. So we are going to check if trend is greater or equal than 0. So, then we are going to increment the result and use the reset. So finally we can return the result. So let's change this one to be V1. So V1 is more compact. The V2 is so let's check the generic case. So let's check the So I would say so for this version, you just don't need to think, just follow your thought. And for the second one, we pick the cases that the monotonicity changes. So one point to be noticed that is the trend can be 0 in the procedure only when in the very beginning. So because in between, if the trend is 0, it does not produce new monotonicity. In effect, it does not increase the length of the vehicle subsequence. So overall, that's the solution. So again, to emphasize the simple idea, so for each number we are looking at, we just need to check if it produces new trend. If so, we increment the result by 1 and then reset the result, the trend. So that's all about it. Thank you very much.